5, a stress string PQ has a length of 1.2 meter. So PQ has a length of 1.2 meter. One end of the string is attached to a vibration generator. So one end is attached to a vibration generator, that is, this is the vibration generator, and the other end is attached to the wall, as shown in figure 5.1. The vibration generator is switched on. So the vibration generator is switched on and a stationary wave is formed on the string. So the vibration generator is switched on, that is, the generator vibrates, and a stationary wave is formed on the string. Now you have to remember that the wave that is produced is a stationary wave and not a progressive wave. The string is shown at one instant of time in figure 5.2. So this is the string at one instant. Explain how the stationary wave is formed between the vibration generator and the wall. So how the stationary wave is formed? So wave from the vibrator, wave from the vibration generator. So wave from the vibration generator is reflected by the wall. So wave is reflected by the wall. The incident wave and the reflected wave superimpose to form a stationary wave. So the wave from the vibration generator is reflected by the wall. So as the vibration generator vibrates, so the wave from the vibration generator is reflected from the wall. And as the waves reflected, so the incident wave superimpose with the reflected wave. So as the incident wave superimpose with the reflected wave, and thus a stationary wave is produced. So the wave from the vibration generator is reflected. You have to remember that it is reflected. So it is reflected from by the wall, and since it is reflected, so incident wave and the reflected wave superimpose to form the stationary wave. And what is superposition? So superposition or superpose by principle of superposition. So the principle of superposition states that when two or more waves meet at a point, the resultant displacement at that point is equal to the sum of the individual displacement of the individual waves at that point. So the principle of superposition states that when two or more waves meet at a point, the resultant displacement, so resultant displacement is equal to the sum of the individual displacement d1 and d2. So the principle of superposition states that when two or more waves meet at a point, the resultant displacement is the sum of the individual displacement. So resultant displacement is the sum of the individual displacement. Then calculate the wavelength of the stationary wave. So we need to find the wavelength. So here the total distance is given is 1.2 meter. So the total distance is 1.2 meter, and to cover this total distance, this is one wave produced and half the wave produced. So one wave is produced, one lambda is produced, and half lambda is also produced. So one wave, that is from this point to this point, and half wave, that is from this point to this point. So in total 3 by 2 lambda is produced. So 3 by 2 lambda or 3 by 2 wave is produced. That is 3 by 2 is 1.5 lambda is produced. So 1.5 lambda is produced. So what is the value of lambda? Lambda is 0.80 meter. So 0.80 meter, that is 0.80 meter, that is approximately 1, 2. So 2 significant figure. And lambda, that is the wavelength, is 0.80 meter. So this is 1 lambda and this is lambda by 2. So this is covered in 1.2 meter. For part C, figure 5.3 shows the stationary wave at time t is equal to 0 when all the points on the wave are at their maximum displacement. So when all the points are at their maximum displacement, the period of the wave is 0.16 second. So the time period is 0.16 seconds. On figure 5.3, sketch the shape of the stationary wave at time t is equal to 0.24 seconds. So what is the sketch of the wave at 0.24 seconds? So you have to remember that this wave is a stationary wave, and for a stationary wave there is no movement at the nodes. So the nodes remains at their position. So there is no movement at the nodes while the antinodes move. So for 0.24 seconds, so for 0.16 second, we know that for 0.16 second, the antinode moves from the top to the bottom and then again move to the top. This is for 0.16 second. Now for 0.24 second, so for 0.16 second, so as one complete wave is produced or the time period, so it moves to the bottom and again move to the top. So it has covered 0.16 seconds. So 0.24 minus 0.16, we get a time of 0.24 0.08. So what is the movement now for 0? So what is the movement for 0.08 second? So first of all, for 0.16 second, it moves down and again move up to complete one wave. Then it covered 0.16 second, and for 0.08 second, so it moved. So for 0.16 second, first of all, so 0.16 second, it moved down from the topmost point to the down. So from the topmost point to down, then again down, then up, then again up. So here we can see that this topmost point is moving downwards and then upwards. So downward and then upward. So this total time is 0.16 second. That is from this point to this point, that is 1, 2, 3, 4. So for four movements, the total time is 0.16 seconds. So for one movement, what is the time? That is 0.04 seconds. So one movement means that from the topmost point to this point is 0.04 seconds. So from the topmost point to this point is 0.04 seconds, and for 0.08 second, it moves from the topmost point to this point, that is 0.04, plus an additional 0.04, that is from this point to an additional 0.04 seconds to the bottom point. So now here we can see that it moves to the bottom point. Now if we just draw the points, then antinodes have no movement, while for the nodes have no movement. So nodes have no movement. Now for the antinode, so this point moves from the topmost to this point at 0.04 second, then again 0.04 to this point. So now the antinode is this point. Similarly, this antinode at 0.08 second moves to this point. So this point, then this antinode is at this point. So if we just join the points, then the displacement would be like this. So this is the movement of the wave at 0.24 seconds. Nodes have the movement, and for 0.16 second, it completed one wave. So after completing the one wave, it moved to down and again up. So from down to up, it comes to its original position. Since it comes to its original position, so it is now at this position. Now for additional 0.08 second, so additional 0.08 second, so this movement is 0.4, then again 0.4 to complete 0.8 second, and now this is at this point. Similarly, this point, the bottom point is at this point, and this point 1, 2. So at this point, so after drawing, we get this diagram. Then point R and T on the string are a horizontal distance of 0.30 meter apart and in positions as shown in figure 5.4. So R and T. State the phase difference between the oscillation of point R and T. So what is the phase difference? So what is the phase difference between R and T? So remember that, so this is the stationary wave. So for stationary wave, there is nodes, 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 and nodes, and the topmost point is the antinode. So as we can see that point R and point 2 T are separated by a node. Since the points are separated by a node, so the phase difference would be 180 degree. This is an important thing, that when the 2 points are separated by a node, the phase difference is 180 degree. Now let's suppose if the 2 points are within the same node, that is this node, and the 2 points are within the node, that is within the node. So since the 2 points are within the node, so the phase difference have to be 0 degree. But let's suppose if the 2 points are separated by the node, that is this node, if the 2 points are separated by the node, then the phase difference is 180 degree. But if let's suppose the 2 points are within the node, that is suppose for this node, if the 2 points are within the node, then the phase difference is 0 degree. Similarly, right now, point R and T, so point R and T are separated by a node. Since the points are separated by a node, so the phase difference is 180 degree. Then state the speed of the progressive wave of the straight string. So we need to find the value of speed. So V is equal to F lambda. So V is equal to F lambda, and what is the value of velocity? So we need to find the value of velocity or the value of speed. So what is the wavelength or an information? So we have given the time period, that is the time period, and we know that frequency is equal to 1 by time period, that is 1 by 0.16. So frequency is equal to 1 by time period, that is 1 by 0.16, that is 6.25 Hz. So we know the value of frequency. Now what is the value of wavelength? So what is the value of wavelength? Now for the wavelength, so we know the value of wavelength, that is 0.80 meter. So the wavelength for the wave is 0.80 meter. So the wavelength is 0.80 meter. After substituting the value, we get a speed that is 5 meter per second, 5.0 meter per second, to significant figure.